So, title, my title. I don't want to see your title. I don't want you to adapt your title. I don't want you to change it. It's my title. It's mine. Give it back to me. Purpose, big paragraph. What did you do? What are you going to find out? How are you going to do it? Make sure you describe buoyancy. Explain it. Make sure there is a place, a URL. You put wikipedia.com, and what you're basically saying, if you put wikipedia.com, is, Mr. Moreno, please take 3 points off. I want it. I want 3 points off. I will give you what you want. Yes, Havana. Yes. And yes. Copy and paste the URL, man. You can't get. No. What are you talking about? Buoyancy. Look up buoyancy on Wikipedia. Copy and paste where you found the explanation.
Well, I'm talking about like how we have to look up the density for.
No, that one I gave it to you.
Okay.
All right. Hypothesis. Okay? No, yes, or no. I want the answer to the question. If then statement. What did you change? What did you change? What were you changing? Remember back, what were you changing? This is not a rhetorical question. What did you change that allowed the polymers to separate? Yes, Caitlin. Okay, by having different amount of salt, what did you change? The density of the water. What were you able to do because you changed the density of the water? So if you blank, then you will be able to blank, whatever. Don't put you. You is a personal pronoun. Folks, a controlled variable, it's controlled variables. I will expect to see at least 2 of them. Okay.
Wait, can you spell so I can get the background?
Nope. That's already been emailed to you.
Oh. Okay.
Here's the part that hasn't. Let me erase this from previous class. Data. What data did you collect? What did you measure? Okay, so there are 4 masses you collected of the individual particles, individual polymers. What else? The total mass. So we should have, let's see, for those of you who do not know how to make tables, go to Insert, Table. We just need 2 columns, right? 1, 2, 3, 4, 5. Is this right? We can always create another one. Okay, so the first thing was the mass of, help me, we're wasting time, all polymers. I'm making this number up, 34 point, how many decimal places? If you do not have 3 decimal places, you're demanding that I take points off. What unit? Okay, you can have it there or you can have it right here. By putting it right there, you're defining that everything in that column, in that row, is in grams. What's the next thing? Mass of cloudy. 2.35345. Is that right? I don't know. I'm making this up. Then any questions on data? Is that all the data we collected? What happens if I see percentage in this table? What are you basically asking me to do? If I see a calculation, take 3 points off. So I'm not going to see a calculation, am I?
No.
All right. So here comes the calculation section. What did you calculate? What do I want to see? I want to see the mass percent. I want to see the percentage of cloudy. How do you do the percentage of cloudy? Thank you, Emily. So it would be 2.345 divided by 34.286. And that equals, I don't know what that equals. Let's see.
Would you have percentage error on this?
No, how can there be percentage error if there is no true value?
Just like if we happen to get a different like number for like the grams per polymer than you gave us.
Everyone's going to be different. All right, so 2.345 divided by 34.286. And my calculator says, times 100, right? My calculator says 6.839526 grams. Okay, how many points are they going to lose? Everything is 3 points. How many points are they going to lose? 3. And they're going to lose another 3. Can you tell me what 6 points they're going to lose? Catherine. That's right. How many sig digs? How many sig digs? How many should you have? Okay, so you need to round that 9. Oops. So it looks like it's going to be 40. What else is wrong? What the heck? Why is it in grams? You're asking, who would do something like that? Some of you did. Percentage error in grams per milliliter. It is percent, folks. Percent. Bam. Percent of, what's the next? Blue? Percent. Percent. That's not percent. Percent. Is there a percentage error? No. No. No percentage error. No percentage error. Well, Mr. Marino, should I put a percentage? No, don't put a percentage error. That's what no percentage error means. See, what happens is I pummel you guys so mercilessly that when the labs get easier, you guys start going, I must do more work. No, don't do more work. No percentage error. Yes, Savannah.
Okay, so percentage error, this is not for this like specific lab, but percentage error goes in calculation.
Yes. Yes.
So the calculations be like in a table, or
They could, or they can just be like this. Either way, I need to clearly see what it is. Yes?
in the lab calculations, in the last lab calculations, percentage error, you have to tell where you got it. Do we have to tell where we got the numbers from error?
No, that is obvious. What happened with you guys, with many, like as in 90% of you guys, is you gave me your observed value for your density. And then you gave me the true value. But if I am in another country reading your lab report for the first time, I'm going, where did this number come from? Where did 2.70 come from? What happened? Where did they get 2.70? What you should have done is you should have said 2.70 grams is the per milliliter is the density of the true value, which was propylene. Now I know what 2.70 is. So those of you who got, what is it? Question mark. I needed to know where the 2.70 came from. What is it? You should have said 2.70 grams per milliliter is the density of true value propylene. Then I would have known, 2.70. Have you heard the old phrase, the devil's in the details? No, never? I'm the devil.
Yeah,
Okay, yes, I know. Folks, most of you will be eventually in a job making money where the details are important. So up until now, you've really not had to deal with this kind of stuff. That's why this is so hard. I'm teaching you guys how to recognize how detailed things need to be. I'm trying to help you. Okay? Ask your parents whether details are important in their jobs. Okay? Unless they are landscapers where they're moving tons of soil from one section to the other, they're probably going to say yes. Yes?
For like percentage error, like, or just as big digs, like, if you have to make 8.011, would that O be
That's
a
three.
big dig?
8.0, yes, yes. Any
Oh.
zero between numbers is a
Okay.
significant digit.
I wasn't sure if it was like
Yep.
just because it was after the decimal.
Data analysis. Summarize what you found out. This is where you tell me what the answer to the questions are. In the last lab, many of you guys told me, yes, as mass increases, volume increases. Yes. But what was the second question? What was it? You didn't tell me what it was. And you also described problems you encountered. That conclusion better be so big that I'm tempted not to read it. I'm tempted just to skim it. No reboots. No reboots. You know what's the easiest thing to do? Find your variables, right, that you controlled for. Change one of them. Change one of them. Keep your independent the same. Change one of the variables. That's the easiest way to come up with a sequel. No graph. No graph. Easier lab. Easier lab. No graph. Any questions? Any other questions? Forever and always.